This is Edexcel Further Pure 1, Trigonometry, the T formula, and in particular the application of T formula to trigonometric equations. Here are the T formulae: sine theta, cos theta, and tan theta, all in terms of T, where T is tan theta over 2. And to help us remember those formulae, we've got the two aide-memoire triangles. The T formula are sometimes useful in solving trigonometric equations. In this two-part question, we're asked to use t equal to tan theta rather than tan theta over 2. So we're likely to have to replace a double angle, a 2 theta angle. And sure enough, in the equation that we're supposed to be transforming, there is a cos 2 theta. And there is a hence in the second part of the question. And that hence really means use the first part to solve the second part. And we're given a range and all the other information that we need to do to complete those questions. Here is my original equation, and we're asked to use the substitution t equals tan theta. For the first term in the equation, that's just going to be t squared. But for the second term, we've got cos 2 theta. So I'm going to need to use t formulae for that. So up on the right hand side here, I've drawn out my triangle with the acute angle being 2 theta and the various lengths around the side there that help me remember the t formula. So the adjacent is 1 minus t squared, the opposite is 2t, and the hypotenuse is 1 plus t squared. And so you can see cos 2 theta is going to be adjacent over hypotenuse. So 1 minus t squared over 1 plus t squared. So now I've got expressions in terms of t for tan squared and cos 2 theta. I can just simply substitute those in. So tan squared theta becomes t squared. Then I've got 4 lots of cos 2 theta. I need to substitute in that expression 1 minus t squared over 1 plus t squared. And that equals 1. To remove this fraction, I'm going to need to multiply it by 1 plus t squared, making sure I multiply all terms by 1 plus t squared. So the first term is t squared, and I need to multiply that by 1 plus t squared. That is going to give me t squared plus t to the 4. Then I need to multiply the numerator of this fraction by 4, so I get plus 4 minus 4t squared. And not forgetting to multiply the right-hand side by 1 plus t squared, I get 1 plus t squared. Collecting all terms on the left-hand side in descending power order, if I look, I've got just t to the 4. Looking at the terms in t squared, I've got a t squared and a t squared on either side of the equation, so they cancel out. I'm just left with minus 4 t squared, and then 4 take away 1, that's 3, and I've set the right hand side to 0, and that is the transformed equation as desired. And here's that first section written out neatly so that you can freeze the video if you need to follow that through in more detail. So there is a hence in this second part, which means that we should use the first part to solve the question. So we've transformed tan squared theta plus 4 cos 2 theta equals 1 into a formula purely in terms of t, where t equals tan theta in this case. If we look at this equation, we should be able to identify that actually it's a quadratic, but it's a quadratic in t squared, and that factorizes quite readily. Sum of two numbers is minus 4, product of two numbers 3, that's going to be negative 3 and negative 1, so t squared minus 1, t squared minus 3 equals 0. So t squared equals 1 or 3. T, which is tan theta, equals plus or minus 1 or plus or minus root 3. And these are values that you should know. So theta is going to be equal to, when tan theta equals 1, that's pi over 4. And when tan theta equals minus 1, that's 3 pi over 4. And tan repeats every pi, so now I've got these two values. Another value would be 5 pi over 4 and 7 pi over 4. And those are all the values for plus and minus 1 in the range 0 to 2 pi. And then for root 3, positive root 3, that will give me pi over 3. And for negative root 3, it'll give me 2 pi over 3. And then adding pi onto those, that'll be 4 pi over 3 and 5 pi over 3. And those are all the solutions. And here you can see that written out more neatly, and you can freeze the video if you want to follow that through in more detail. In this example, we're asked to use the substitution t equals tan theta over 2. So we're going to need to use the t formula for expressions for both sine theta and cos theta. So sine theta is 2t over 1 plus t squared multiplied by 3. That will give me 6t over 1 plus t squared. The expression for cos theta is 1 minus t squared over 1 plus t squared. And then there's the plus 3, and that all equals 0. Multiplying up by 1 plus t squared to remove the awkward denominator will give me 6t minus 2 times 1, that's minus 2, minus 2 times negative t squared, that's plus 2t squared. Not forgetting to multiply the 3 by 1 plus t squared, that gives me 3 plus 3t squared. Collecting terms, we've got 5t squared, just the 6t, and negative 2 and a positive 3, that's plus 1 equals 0. Factorising, we end up getting 5t plus 1, t plus 1, equals 0, so t equals negative 1/5 or negative 1. Now t is tan theta over 2, so if I inverse tan those two values, I'll get my value of theta over 2. Now I can see that I need to give the answer in terms of degrees because the question asks for it, it gives the range in degrees. And it's quite a wide range, so we probably need to take account of how tangent repeats. Well, tangent repeats every 180. So if we have 180 multiplied by an integer, and then put in the values, so for negative 1, I get negative 45. And for negative 1/5, I get negative 11.3 degrees. So doubling up for theta, 360 n minus 90 degrees, or 360 n minus 22.6 degrees. Now we've only got one value. You see theta is now repeating only once every 360, and so there's only going to be one value for each of those. So we've got 270 degrees or 337.4 degrees. And here's that solution written out somewhat more neatly, and there's the aide-memoire triangle there to help you through. So if you want to follow that through in more detail, you can just freeze the video at this point. Here are our three t formulae, where t is the tangent of theta over 2. You've got the aide-memoire triangles, and as we've seen through this video, that can be useful in solving trigonometric equations. That was Edexcel, further pure 1, trigonometry, the T formula, the application of the T formula to trigonometric equations, and that concludes the T formula set of videos.